Okay, in this lesson we're going to look and make tree diagrams. So the situation that we have in this problem right here is that a group of students are having a corn maze, and these corn mazes can, or depending on what path that you take, it's going to either lead to pumpkins or no pumpkins. So the first thing we're going to do is create a tree diagram that breaks down all of the options, and then from there we can find the probability of if you take this corn maze, if you're going to walk out with a pumpkin or not. So when we create a tree diagram, we're going to have our starting point. So this is where we all start at. So the best way to look at it is if you're right here, your first option is you can take this upper path, the middle path, or the lower path. So you got three options there. So I'm going to create 3 arrows right here that show that. So here's my upper, here's my middle, and then here is the lower. So the way that we're going to do this is for the fact that there's 3 options here, the chances of picking one of those would be 1 out of 3. So I'm going to put a fraction behind each of these to express that. Okay, so then after we do that, we can just pick a path and then go through the amount of options that they have there. So if I take the upper path, so I go this way, I come across another fork in the road there, so I got to make a split decision there. So there's 2 options there, so I'm going to write 2 arrows that express that. If I take this top part, that leads to no pumpkins. And then if I take the one below it, that's going to lead me to pumpkins. So that's going to be 1/2 for each of those. I have a 50-50 shot or 1/2 on each of those. The middle path is pretty easy. It leads straight to pumpkins. I don't have to worry about anything there. So the way I'm going to express, I'm going to put pumpkins, and I'm just going to put the fraction 1 because you have one option there, 1 of 1. So you don't have to worry about a decision there. But if you pick the lower path, you're going to come across a decision there as well. So if you take that upper part of the lower path, that's going to lead to pumpkins. And then if you take the lower path, that's going to lead to no pumpkins. So again, each of those is 1/2. So here's all of our outcomes right here in red. And after we do that, we can establish the probability for getting pumpkins or no pumpkins. So the way that we do that, if I take there's really 5 outcomes that I have right here in red. What I'm going to do is just multiply those 2 fractions together. So from there, I can be able to determine what's the probability of taking that path. So for the one that I would pick the upper path and that leads to no pumpkins, I come across a third and I come across a half. So I'm going to say 1/3 times 1/2. So that's going to give me 1/6. So there's a 1/6 chance that I take this path and I get no pumpkins. Same thing for below. It's going to be 1/3 times 1/2. So I'm going to get 1/6 as well. So 1/3 times 1/2. So each of those is going to be 1/6. I'll come back to the middle really quick, but if you look at the lower, it's going to be the same thing happening there, where I got 1/2 times, or 1/3, times 1/2. So it's going to be 1/6. 1/3 times 1/2, which is also going to be 1/6. Lastly, I have my middle path. I got 1/3 times 1, so that's just going to be 1/3 there. After I go through all of this, one way to kind of double check yourself to make sure you did it correctly is if you add all of these fractions up, you should get it should equal 1, or it should be 100%, which should make sense. If I add 1/6, I'm going to get 2/6, which reduces down to 1/3. So 1/3 here, 1/3 between those, 1/3 between those 2/3, and of course if I add that in, that will get me what I want, 3/3, which equals 1. So from here, the last step that we have, get a different color, is to get our combined probability of this. So I'm going to write right here, last step. So now I can figure out what's the probability I walk away with a pumpkin and probability I don't walk away with a pumpkin. So looking at my pumpkin, what I'm going to do is add my fractions there, because I'm going to add my probabilities, and that combined total is going to represent the total that I have overall through this entire maze of walking out with a pumpkin. That's going to be 1/6 plus 1/3 plus 1/6. So remember, when you add fractions, you got to change to a common denominator. So this 1/3 will become 2/6. So when I add that together, I'll get 4/6, which equals 2/3. And then for no pumpkins, I'm going to do a similar thing where I'm going to add all of those that represent no pumpkins. So from there, it's going to be 1/6 plus 1/6, which equals 2/6, which equals 1/3. So the probability of walking out the pumpkin is 2/3. Probability of not walking out the pumpkin is 1/3. So we're going to use that to answer the question right below this one, which would be number 2. All right, so taking a look at number 2, it says that if we have 50 customers, how many would walk away with pumpkins? So this is a really good kind of real-world question here. So I'm going to take my 50 customers. The probability of one customer winning would be 2/3. So to figure out how many of those 50 would walk away with a pumpkin, I'd multiply those together. So when you do that, you get 33.5 right there. So obviously you can't have 0.5 of a person walk away with a pumpkin, like they're not going to take half of one. So we can say between 33 and 34 customers. If you were running your own, or if this was you being in charge, it would be smart to go with 34, just to be safe there, so you have that extra pumpkin available. But we would expect somewhere between 33 and 34 customers to walk away with a pumpkin in this situation. Okay, so looking at number 2, wants us to create a tree diagram of all of the possible sandwich possibilities. So we have 2 choices of bread, we have 3 choices of meat, and we have 4 choices of cheese. So we need to create a tree diagram. So there's not going to be enough room unless I turn it side, or if you look at it sideways. So I'm going to split this tree diagram up. So you would have a starting point, and that starting point would lead to your 2 bread options. And then from those 2 bread options, each of them would have the 3 meat options, and then each of them would have the 4 cheese options. But I'm going to split it into 2 just so I have some room. So I'm going to have white and then wheat. So the way I'm going to express these is that I got a 50-50 shot for each of those. So I'm going to write that there. So after I choose that, I got 3 options for the meat. So that could be ham, which is going to be 1/3, turkey, which is going to be 1/3, and then beef, which is going to be 1/3 as well. From each of these, like I said, I'm going to have my cheese options. So just to save some time, I'm just going to put the first initial of each of those. And then I should see that my options for each of these is going to be 1/4. So I'll have 1/4 to represent each of those. And if to make the other side, all of this that you see here, all of this stuff here would be moved right there. So for the wheat option, I would have the 3 meat, and then I would have the 4 cheese. So one thing that would also be good to know is what's the total possibilities I have? How many different types of sandwiches can I make? Because it says you make one of each choice. So someone puts all these different sandwiches, so it's going to kind of how it ties into probability. But it would be good to know what the sample space of this is, or the total combinations when we go through and do this. So your total combinations of sandwiches. So to get that, I'm going to take the 2 bread options, the 3 meat options, and the 4 cheese options, and multiply those all together. So I'm going to get 24 options. I should see right here with my, when I had white bread, I got 12 options, 4 for that, 4 cheeses for that, meat, 4 cheeses from that meat, 4 cheeses from that meat. When I add that all together, I get 12, and of course, wheat's going to have the same amount, so it's going to be 24. So what I want you to do is answer 4 through 9, so the rest of this page. So 24 is going to help you out knowing those combinations, and then we need to find the probability of each. So try those problems on your own, and then we will check over those. All right, so let's quickly look at these problems. Number 4, what's the probability that you select a sandwich with white bread? So it doesn't matter what's on it as long as it's white bread. So of course that's going to be half your option. So that's where this 1/2 comes from. 5 asks about American cheese. There's 4 options for cheese, so the chances of one of those, or American cheese getting picked, would be one of those 4. Number 6, it asks with wheat, ham, and any cheese. So with wheat would be 1/2, with ham would be 1/3, and then any cheese, so 4 over 4. So you're going to multiply those across because of the word "and" right there. So you're going to get 1/6 when you reduce that fraction. Looking at number 7, we get the probability that your sandwich has white bread, either beef or turkey, and has provolone cheese. So 1/4 for your one bread option. They mentioned 2 meat options, so 2 of 3, and then 1/2 in terms of the, I think I have that mixed up actually. So here's your white bread percentage, and here's your provolone cheese percentage there. So I have those switched, but regardless, you should get 1/12 when you multiply those. Number 8, it asks neither beef nor Munster cheese. So if it's not beef, there's 2 other options there. So that's where that 2 out of 3 comes from. And then not that specific kind of cheese, there's 3 others, so 3 of 4. So I'm going to multiply those across, and I get 1/2. And then lastly, in number 9, so I have 2 scenarios going on with the probability of ordering ham sandwich on white. So right here in red represents that, so I get 1/6. Turkey with provolone cheese, so right here in green represents that, I get 1/12. And then because there's an or right here, I'm going to add those together. So add them, change, and get a common denominator. And I get 3/12, or when I reduce that down, I'm going to get 1/4, so a 25% chance there. So there's still 2 more problems in this section. I'm going to split that into a part 2. So this is part 1. So make sure you watch part 2, and we're going to look at Haley. You kind of see her down here. And then we're going to look at a council in the next scenario that finishes off this section.